graphing problem. You're given y equals f of x, so it looks like this big swooping sort of thing. And then it says to graph y squared equals f of x. Well, y squared is a little funny, so take y squared equals f of x. And then if you solve for y, you get y equals plus and minus root f of x. So we actually have y equals root f of x, which is one function, and then we have y equals minus root f of x. So it's a little interesting. So we got to graph both of them. Well, here's the original here. You see that we're just going to start taking some square roots. So the square root of 0 is 0, so it goes through here. You see right here it goes through about 1.5 and 4. So if I take the square root of 4, that's 2. And then if we take the square root of 0 again, we get 0. And the same thing over here, goes to 2 and goes to 0. So it should look something like this. Okay, so that's this one. And then we need the negative, so we actually flip it as well. So it goes down to 2 again, or down to negative 2. And it's the same thing. So it looks sort of like this really cool butterfly. Something like that. Okay. Another one. This one's a tad bit more difficult. So it says to graph y1 divide y2. So here's y1. Do this one in blue. y1 is in blue. And y2 we'll do in red. And then we'll do the new one in green. Okay, so the first thing we need to look at is when these things cross, I would say. So when they cross, so this is about 1.8, 1.9 or so, divide 1.9. Okay, we know that's 1. So it goes through 1 right here. So 1 is about right there. That's about 1. And then right here, they cross again. But they're both negative, so that means a negative divide a negative is a positive, so it'll go through right there. Okay, so that's the first thing. Do they cross? Let's just start making a little list here. If they cross, they go through y equals 1. The second step, maybe we should do some x-intercepts. So x-intercepts. So if I set 0 equal to y1 over y2, I multiply by y2 on both sides, I get 0 equals y1. So where y1 has an x-intercept, y1 over y2 also has an x-intercept. So we just follow y1 here, and we see that right there, y1 has an x-intercept. So therefore, this rational function also has an x-intercept. The next thing would be asymptotes. Vertical asymptotes more specifically. So vertical asymptotes happen when there is a 0 on the bottom because we can't divide by 0. So when y2 equals 0, we have vertical asymptotes. So when y2 equals 0 is right here. Vertical asymptote there. And when y2 is 0 right here. Okay, and then we'll play sort of a plus-minus game here. So we know that the function has to approach these two vertical lines, but we just don't know which way. So let's play with the middle here first. We have, this is negative, that's a negative, and this is a positive. So when I divide a negative by a positive, it's negative. So the vertical asymptote must go like this, and then we see that it has to cross the x-axis. And then right here, until this value, it's negative divide a negative. That's positive, and we see that it has to go through 1, and it has to hug the asymptote. Okay, and then this piece, let's see, is a positive divide a negative, and it has to hug the asymptote. So maybe something like that. You don't have to be too specific down here because we don't really know what these functions are doing. And then this is a positive divide a positive, and it has to hug the asymptote, and it has to go through 1, so something like that. And that's about as specific as you need to get. I believe the mark scheme mostly focuses on this inner area here.